The following subsection explain program 1.1 line by line. 1.2.1 comments. The first three lines in program 1.1 are comments. A single line comment is designated in C++ with the double forward slashes. Everything on the same line that follows the double forward is part of the comment. C++ also supports a multi-line comments where everything between forward slash asterisk forward slash pair is part of the comment. For example, forward slash asterisk, this is a multi-line comment, asterisk forward slash. Note also that by using the forward slash asterisk forward slash style comment, you can comment out part of a line, whereas a double asterisk comment always comment the entire line. For example, cout hello forward slash asterisk print first name asterisk forward slash first name n. Here we have inserted a comment forward slash asterisk print first name asterisk forward slash in the middle of a code line. In general, forward slash asterisk forward slash style comment out only what is between them. Observe that comments are highlighted in green in Visual C++.NET. Comments are strings that are ignored by the compiler. That is, when the compiler compiles a code, it skips over any comments. Their main purpose is to make notes in a program. For example, at some point, you may write some tricky code that is difficult to follow. With comments, you can write a clear English or some other natural language explanation of the code. Writing clear comments becomes especially important when working in teams, where other programmers will need to read and modify your code. For instance, you may have a piece of code that expects a certain kind of input, which may not be obvious to others. By writing a comment that explains the kind of input that's expected, you may prevent your co-workers from using your code incorrectly and wasting time. Furthermore, the code that was obvious to you 3 months ago might not be so obvious today, so maintaining useful comments can be beneficial to you as well. Note that throughout the above discussion, we state that the goal is writing clear and useful comments as opposed to bad comments. Good comments are clear, concise, and easy to understand. Bad comments are inconsistent, out of date, ambiguous, vague, or superfluous, and are of no use to anyone. In fact, bad comments can even increase the confusion of the reader. As Bjarne Tistrup, the inventor of C++ language, states in the text, the C++ programming language special edition, writing good comments can be as difficult as writing the program itself. It is an art well worth cultivating. 1.2.2 White space. Between the comments and the pound include lines, we have a blank line. Blank lines or spaces are called white space for obvious reasons. The important fact about white space is that the compiler ignores it, although there are some exceptions. We very well could have multi-line space, multi-spaces between the words, and multiple C++ statements all on the same line. From the compiler's point of view, the following code is equivalent to program 1.1 from section 1.1.3. We did that in the previous we did this code in the previous program, so I'm going to skip over this and go to let me read the include directive, because this explains what all the comments and directives is all about. In the program we write, we will need to use some code but we did not write ourselves. For this course, most of this other code will be found in C++ standard library, which is a set of C++ utility code that ships with your C++ compiler. For example, of useful code which the C++ standard libraries include are code for outputting and inputting data to and from the console window, function for comments, various math operations such as sine and cosine, random number generators, code for saving and loading files to and from the hard drive, code to work with strings. This is of course much more functionality to the standard library Van just described, and we will become more familiar with it as we progress throughout the course. Note that there are entire volume dedicated to just C++ standard library functionality. We know that we will use a code from C++ standard library, but in order to do so, we must include some standard library code in our code. To do this, we use an include directive, #include file. In our first example program 1, we invoke two include directives, #include, then forward, then istream, #include string. The first include directive instructs compiler to take all the code in the specified file, the file in between the angle bracket, istream, and include, that is, copy and paste it into our .cpp file. Similarly, the second include directive instructs the compiler to take all the code in the string and include it in our CPP file. istream and string are C++ standard library header files which contain C++ standard library code. Note that in addition to including C++ standard library header files, your program links and standard library files as well. However, this is done automatically. The C++ standard libraries are linked by default when you create a new C++ project. Namespaces. Namespaces are of code as folders are to files. That is to say, as folders are used to organize group of related files and prevent file name clashes. Namespaces are used to organize groups of related codes and prevent code name clashes. For example, the entire standard library is organized in the standard std namespace. That is why we have to prefix most of our codes in program 1.1. Essentially, the std : prefix tells the compiler to search the standard namespace folder and look for standard library code we need. Of course, prefixing all our code library with std : or other namespace can become cumbersome. With the user namespace X clause, you can move codes in particular namespace to the global namespace where X is some namespace. Think of the global namespace as the working folder. You do not need to specify the folder path of a file that exists in the folder you will be currently working in, and likewise you do not need to specify namespace and accessing code in the global namespace. The following revision of program 1.1 include a namespace std clause, which moves the code in the std namespace to the global namespace and such. We no longer need to prefix our language library code with std : prefix. Program 1.3 print string with using namespace std clause. #include istream, #include string, using namespace std : int main, string first name, cout, enter your first name and press enter. In first name and hello first name. Note that we can use more than one namespace. For example, if you had defined another namespace called math, you could write using include math, namespace math, using namespace std, with namespace folder analogy prefixing standard library code, and using namespace X clause are all you need to know about namespace for now. Note, however, that there is much more to namespacing than we covered here, such as creating your own namespace, but we will defer a more detailed discussion in chapter 5. The main function. The main function is special because it is the entry point for every C++ program. That is, every C++ program starts executing at main. Consequently, every C++ program must have a main function. The code inside a function corresponding curly braces is called the function body or function definition. We'll discuss in more detail what we mean in the term function in chapter 3. For now, just understand that the first instruction in main function body is the first instruction executed by the program. In C++, the curly braces are used to define definition and end of logical code unit. For example, the code inside the braces of main define the main function main. The opening braces denotes the beginning of a code block, and the closing braces denotes the end of a code block. Braces are always to be paired together. A beginning brace must always have an ending brace. std::string. std::string is a C++ variable type, more on variables in section 1.3, that represents a string of characters, that is, text using constructing words and sentences. For example, hello and this is a string are both strings. As you can tell by the std prefix, prefix, std::string is part of the C++ standard library, and in order to use it, you must write the include directive, #include string. In our example program, we declare a std::string variable called first name. The variable name can be almost anything we want with a few exceptions. See section 1.3.32 and define it to be an empty string, that is, this std::string variable first name will be used to store, that is, save the first name the user enter into the program. std::string is a powerful variable type, and we will return to it in detail in chapter 6. But for now, it suffices to know that it is used to store text string. Input and output with std::cin and std::cout. Program 1.1 is able to output and input data to and from the console window by examining the code of the program 1.1 and its corresponding output. We might guess that std::cout outputs the data to the console windows, and std::cin not forward slash, it's greater than input information from the console window. This guess is in fact correct. Observe that std::cout and std::cin exist in the std namespace, and to use them we must write the include directive, #include istream. For example, in program 1.1 we display the text enter your first name, press enter to the console window with the following bar: std::cout << enter your first name and press enter, then semicolon. We prompt the user to enter his and her name with the following line: std::cin greater than the first name, semicolon. The statement std::cout std::end semicolon instruct the compiler to output a new line. As a result, the program will move the cursor to the next line for either input or output. Finally, we can chain output together with separate insertion per line, as we do with this call: std::cout hello first name, std::end std::end semicolon. Here we output hello, the following to the string value stored in the variable first name, followed by two new line commands. We can also chain input together, and this will be discussed later. Note the symbol less is called insertion operator, and the symbol forward is called the extraction operator. So the double less is called the insertion operator, and the symbol forward greater than is called the extraction operator. These names make sense when we consider when lesson is used to insert data into outbound stream of data, and the greater than, which is the extraction operator, is used to extract input from the inbound stream of data. Important note: so far, almost every line of the code in program 1.1 has ended with a semicolon. These are examples of statements. A statement in C++ instructs a computer to do a specific action, such as create a variable, perform some arithmetic, or output some text. Of particular importance is a statement of ends with a semicolon, not a new line. A semicolon ends a C++ statement, much like a period ends an English sentence. We could very well have statements that span multiple lines, but for readability purposes, this usually is not done. Variables. In program 1.1, we ask the user to enter his or her name. The program then says hello to that name. The computer knows what name to say hello to because we save the name the user enter with the line std : cin insertion first name. The command line std : cin insertion prompt the users to enter some text, and when he enters it, the program saves what was entered in a string variable called first name. Because the string has been saved, we can output the string with the following line: std : cout insertion hello insertion first name insertion std : end all end l insertion std : end semicolon. A variable outputs a region of physical system memory and stores a value of some type. There are several built-in C++ variables type which will allow you to store different types of value, and as you will learn in later chapters, you can even make your own variable type. The following table summarizing the C++ variable type. std : string used to store string verbs. Note that std : string is not part of the core language but part of a standard library. Char character used to store single line variables such as a, b, c, etc. Usually this is an 8-bit value, so that it can store up to 256 values. Enough to represent the extended AC2 character set. See appendix A for a table of extended ASC2 character set. Observe from ASC2 table that characters are usually represented with integers, and thus character type is really an integer but interpreted by a character. Int, the primary type using to store an integer value, which is numbers. Short typically stores a shorter range of integer than int. Long, assign integer type that typically can store a longer range of integer than int. Float, used to store floating point numbers, that is numbers with decimal like 1.2345 and negative 32.985. Double, similar to float but typically store floating numbers with greater precision than float. Bool, used to store truth handles, that is truth or false, truth values, that is true or false. Note that true and false are C++ keywords. Also note that C++ 0 is also considered false, and by any non-zero value, negative or positive, considered to be true. The exact range of values each type can hold or amount of memory that each type occupies is not noted in the table because these values are largely platform dependent, and a character may be 8-bit, 1 byte on some platform may also be 32 bytes on another platform. Thus, you may usually like to avoid making assumptions about C++ type in your code, in order that your code remains portable, that is, works on other platforms. For example, if you assume in your code where characters are 8-bit and then move the development of platform to 32 character bit, you will have errors which will need to be fixed. Note that you can use std C out and std C in to output and input these other values as well. For example, consider the following program. // program asks users to enter different type of values. The // program then echoes these character values back to the console windows. Pound include iostream, pound include string, using namespace std int main, declare variable and define them to some default values. Character letter A, int integer equals 0, float decimal equals 0.0f. Cout enter a letter, output. In the letter, get input. So what we're gonna do, I'm gonna write this program. I'm gonna type this program into a text editor and see. I'm gonna follow it on the screen by writing it into the text editor. So let me open a notepad and let me say pound include iostream pound include strings using namespace std semicolon remember when you int remember when you double space the white space, the compiler ignores it, so you can double space int main then open colon double slash declare variable and define default value. The character letter equal this is a single line, yeah. Capital A, just follow along as I'm just writing what the book tells us. I'm just writing the program exactly as it is. Then they put a semicolon. t integer equals 0, semicolon, float dec so dc equal 0.0f semicolon. We're gonna put C out, we're gonna put C out, enter a letter, 2 colon, semicolon, output. Cn, I think that's insertion. As you see, the computer's acting up. Get input, C out. Okay, let me just let me just enter an integer. Output. Cin integer semicolon // get input. Extraction, enter a floating number. I expect you to be writing the code into your text editor into a notepad, and then you're gonna just copy and paste it into the C++ blank program. Semicolon // so not only I expect you to be writing the same program into your notebook. Into your notepad. After seeing integer, the book have // then get input. Okay, so it has no, this one the book has not 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 C in integer. The book has C in DEC. Then on this line it says C out, end all, output, another new line. Now output back, I'm having a problem with my computer. As you see, the line is jumping all over. Now output, I don't understand. Now output back the values. The user entered. Hope you're following along with me still. Some of you may be able to type faster. It says integer colon. Less than insertion, integer, then insertion, end. Then C out, float, Okay, this is the entire thing that's on. This is the entire code, and let me see if the zero and. But I'm gonna put it in. I'm gonna copy it and see if it runs. If I wrote it down the right way. Build. Start debugging. Your builder would like to continue. So what is this a letter zero or a number zero? Hope you're following along. Still, I'm writing the declared. The program asks the user to enter different type of values. V. The program then chooses, then echoes these values back to the console window. Okay, so let me start over with another blank document. New project. Then I'm gonna write part2.cpp next, empty project, finish. copy this. If anything, I change about this the O to 0 if that's the way the book has it. Build project, add a new item, .cpp, add, paste, start debugging. So obviously change that to 0. 0, 0. Part2 CPP source 6 cannot open pawn includes strings, no source file directory. Using namespace std. Oh, I see. This is not curly braces. This is, so let me fix that one. That's the first error I saw. This is supposed to be, yeah. So the number 10, that's the first error. It says expected a. So let okay. Let me start again. Okay, so let me redo it. Copy. Start debugging. Can I open source file strings? So it's saying that the the entire thing is wrong. So let me do this. Let me restart again. And I think it's going to be 0 instead of O. new project again. In 32 console application, add new item, that's CPP. My file, that's CPP, add. Paste. Start to debug. Okay, so obviously this is supposed to be 0. Start debugging again. No operator matches this operand. Define them to some default value. Character letter equal A. I'm redoing the rereading the code and see if I miss anything. int equal 0 float dec equal 0.0f C out, enter a letter. Okay, I can see after that there's a semicolon. That's the first mistake. There will be a semicolon. No, there's supposed to be a letter, colon, then after the bracket there's supposed to be a semicolon, which which ends the output. Semicolon end of the sentence output. Then C in the insertion letter, semicolon, get input. Then C out, enter an integer, colon, bracket, semicolon, output. C in oh, okay, it's supposed to be C in, then integer. So that's a wrong. I didn't write this one right. It's supposed to be C in, then this is supposed to be integer, then semicolon, then get input. Right here, forward slash, then get input. So you gotta be careful and pay attention to what you're writing. And then it was C out, enter a floating number, colon, bracket, semicolon, output. Then C in, DEC, semicolon, get input. Then C out, end, semicolon, forward slash output, another new line. Then when it was forward slash now output back the values the user entered. Then C out, insertion letter, end, semicolon, C out, insertion integer, and then C out, insertion float, yes. So let me copy it this way and see if it loads. Okay, so let me repaste back the new one. Start debugging. This time I put it at 0. This is since there are build arrows. No can open file include string, no console application.cpp. Expected A. Cannot open file include strings, no such file. expect A cannot open file strings console application my file.cpp. What I'm gonna do, I'm gonna stop recording now and see if I can fix why this is giving me problem. Then um, then I'll merge it and restart. Uh, it's telling me can't open the source file console application. So let me start a new project again. C.cpp. Next, empty project, finish. I guess sometimes it is like trial and error until you get it right. But I expect you to be writing the codes not only on the computer but in books, like rereading the text and writing a program by pencil so you can get it right. Add new item, a CPP file. Let me paste. Start debugging. It says cannot open source file string the CPP. Can't open include file strings, no such file directory. Name I'm gonna write my file dot cpp. Okay. Next, empty project, finish. project, add new item, C++ header file, my file.cpp, add paste, start debugging, build. New project, my second file .cpp, Win32, next, create an empty project, add new item, source, paste, start debugging. The program doesn't want to cooperate. Oh, pawn input strings. It's supposed to be string. So that's a second error. Pawn include IO stream. Okay, so add strings. It's supposed to be string. So let me cut, paste, start debugging. Can I open source file strings? Strings. It still says strings. I did correct it. So let me delete, debug again. It's supposed to be strings. operator w/matches. Oh, let me see if I put letters supposed to be capital L. Let me see if there's a if I write A, so letters supposed to be capital L. Because I capital L, no, enter a letter, I put common L. Get input, see out, enter a letter. Oh, okay. See out, enter a letter, then there's supposed to be a semicolon to end it. So debug again. No operator matches these, my two source file. No operator form takes left and operator of type std stream. There's no acceptable conversion. std stream. Using namespace std int main character letter equal a int integer equals 0, float desc equals 0.f, c out, enter a letter, semicolon, output, cin letter, get input. C out, enter an integer, cin cin integer, semicolon, get input. Cout, enter a float number, not floating number, float. Enter a float number, output cndec, get input. Cout, end, output another new line. Now output back to the values the user entered, and cout letter. Okay, so let me build debug, start debugging. I had floating number and it's supposed to be float number. So this time it works. So as you can see, it's very important for us to write the correct word. So this time you can see that it did build. I enter A, enter 2. The float number 0 820. So as you can see, this time it was built, but everything that I went through tells you. I'm going to leave in all the steps that I did, because to show you that you gotta write. I had floating number right here, so it's supposed to be float. So you gotta write it exactly, and you got to know all the declare words and values for C++, because the library didn't have anything with floating. It's obviously float. So what happened? I'm gonna end it right here, but we're gonna continue the course, because eventually we're gonna learn how to do game, how to put game and game mathematics and everything. So I'm gonna end the recording right here, and okay, thank you. I'll see you next course, which is going to be later on today.